My name is John Novitsky. I'm CEO of a company called AquaPrawnics. We are fundamentally shrimp farmers. And you're asking, so what are we doing at a biochar conference? Well, we have a circular economy. Every step that we do is profitable separately. Our sites are zero waste. We're wildly carbon footprint negative, and I'll explain that in a minute. And with each process step we use in our shrimp production, the waste are utilized in the next step. Okay, let me start with the shrimp. We have a proprietary process for producing shrimp, which yields, roughly speaking, about 30 times more than most of the shrimp farms in the world, per pounds per acre per year, and roughly factor 15 times more than the other shrimp farming techniques that are currently in use in the world. Now, why shrimp? So it turns out shrimp are the world's most popular seafood. Roughly speaking, it's the sum of tuna and salmon combined, and those three seafoods together collectively eclipse all other seafoods in the world. Now, our shrimp are also premium because they are chemical-free, they're fresh, never frozen, and they're sustainable. Now, one of the interesting things that we've been studying closely is what happened with the COVID impacts. And COVID and the hurricanes have dramatically reduced the shrimp production in the world, but surprisingly, the imports into the United States are up about 6% year on year, this year versus last year. Now, so start with the shrimp farm. Now you'll understand where we're going with this. Instead of using chemicals, we use pyrolysis. And I first met Josiah Hunt at a cogen site in Northern California, and subsequently visited a bunch of other cogen sites, and found that it was difficult to have a big fixed capital asset like a cogen plant that daily had to go retrieve fuel and bring it to the cogen site in order to make the energy. So economically, then it made sense for us to go put our shrimp farms co-located at a farm which generates ag waste annually, so we didn't have to fetch it. That led to us going to almond orchards here in California, and we have 1.65 million acres of nut orchards in California that are giving us three types of input fuels. We take the dead trees, we take the tree trimmings, and we take the waste almond shells, which have no commercial value. That's the input to the pyrolysis that we use. And when we do this, we generate our own electricity, we generate our own heat to run the indoor shrimp farms, and related, we also burn the syngas, but we pipe the exhaust stack into an algae production area, and we use the algae in two different ways. The algae is used as both a feed for the shrimp. It's also used as an ingredient, again, as Albert talked about, an enhanced photosynthesis. So we're roughly quadrupling the amount of CO2 available to the plants. And if you give 4 times more carbon and give it ideal growing conditions and an ideal light spectrum, guess what? The plants grow 4 times faster. So we also use the algae as an ingredient for soil amendment. Now, we have the pyrolysis also kicks out the biochar, and we use it in 2 different ways. We use it as a soil amendment. It goes right back into the farm from where the carbon came from initially. And then we also use it as a cattle feed additive. As a soil amendment, we're able to eliminate the air pollution that was caused by burning the ag waste. We're able to drastically reduce the water pollution due to runoff of, they call it fertigation. We use fertilizers in the irrigation water. We're seeing that there's something in the neighborhood of about 20% crop irrigation water reduction. And here in California, if we got the entire nut orchard industry to agree to do this, it would be the equivalent of adding an average 13th reservoir for the state of California We only have 12 big water reservoirs, and the last one was built in 1989. We've not built any reservoirs since then. And if we got everybody to do this, all of the nut farmers, that alone would be the equivalent of adding a 13th reservoir for the state. And roughly speaking, it looks like the farmers are going to make about 500 more bucks per acre by using this technique of the soil amendment. So we don't need the other people have talked about doing offsets and carbon tax credits and things. We've set this up fundamentally as a business in a way where the farmers make more money. We don't need that stuff. Now, also when we use this stuff as a cattle feed additive, roughly speaking, the methane is halved, the mortality is reduced, the cows grow 10% larger, they get 10%, grow 10% faster, and there's roughly speaking about a 10% reduction in the food conversion ratio. And roughly speaking, just off the food conversion ratio, the farmer is going to make about 500 more per cow per year. Now, one of the things that makes all this work is we take the solid waste that are coming out of the shrimp farm production itself and mix them with the biochar to form the soil amendment. Those solid wastes are very high in NPK, and of course we're breaking up the soil compaction, we're putting the slow release minerals back into the soil with the farmers, and so on. Okay, so that's how we get to zero waste, and all the pieces are used. Most of the photos here are from a place in the Central Valley of California. Now let's talk about scalability. We can do about 1,000 sites in California just off the nut orchards alone. And if we got to 1,000 sites, that would represent ballpark about 8% of the annual US shrimp imports. If we do this in Vietnam, Vietnam's the world's number exporter of rice, number 2 coffee, number 3 is shrimp. We can co-locate the shrimp farms at about 200 rice paddy sites using the wastes that are coming off the rice paddies that are currently burned because there is no commercial value for them. Those become our renewable biomass, and we can do this at ballpark about 400 coffee plantations. Now, to quantify what's happening here, our standard unit of production is based on 1,500 acres of the waste coming off an almond orchard, and that roughly corresponds to, there's about 23,000 tons of carbon either sequestered or avoided per year per site. And roughly speaking, it's about 23K of that is due to direct carbon sequestration with the biochar mixed in. About a third of it is coming off of carbon that's avoided. And what we did is we calculated the amount of carbon that was produced making a ton of shrimp in Vietnam and transporting it to the United States. And we used Vietnam as an example because it split the difference between India and Ecuador. And India is the biggest importer into the US. Vietnam's number 3 and Ecuador is number 2. So split the difference between Ecuador and India, roughly you get Vietnam. That's how we picked it. And then there's another, roughly speaking, about a third of it is due to the enhanced photosynthesis of making our own algae in the building on the site, capturing the carbon coming out of the waste stack from burning the syngas. Now, roughly speaking, the way this is going to work with the cows, at JJ's Ranch alone, by the time you do all the math, it turns out to be about ballpark about 9K tons of carbon per year. That's either methane that's avoided. The other piece that we're doing the research on, and people talked about water remediation, when we feed the biochar to the cows, there's 2 types of cows there. There's a dairy cow where when the cow poops out the biochar, it's washed into the waste lagoon where it continues to have a remedial effect on both adsorbing the chemicals as well as reducing the amount of methane that comes off the waste lagoon. In the case of the free-range beef cows, when they poop out the biochar, What they do is they stomp it into the ground with their hooves, where it's directly sequestered. We have not yet quantitatively gone through the numbers that figured out what's the value of the biochar that's washed into the waste lagoon. We haven't done that piece yet. So we just did the calculation of what's happening with the methane reduction and what's happening with the direct carbon sequestration of the biochar being returned as a soil amendment into the farm. And I already mentioned what's happening with the irrigation water. Company status is our first site is in production now. It's up in Knoxon, Montana. Our first harvest will be after Thanksgiving, before Christmas, and after that we'll be harvesting weekly. By this time next year, we'll be the largest indoor shrimp farm in all of the Americas. And the way we make the shrimp, where we're chemical free, we're fresh, we're sustainable, and so on, the Monterey Bay Aquarium Seafood Watch already rates us as a green best choice. And then once we have that system up and running, the shrimp production system, the indoor shrimp farm, we can take it and put it anywhere in the world where we can each either buy or make electricity cheaply. And we have many integrated sites that are already in planning and production. And we have many urban sites that are already in planning and production. And typically what we'll do is we will pair an urban shrimp farm that's in a city with a rural site. And the reason why is for every 100 pounds of shrimp that we harvest, we generate something in the neighborhood of 10 to 14 pounds of what's called biofloc, which is the way that we control the waste coming out. And what we do is we then once a week will run the biofloc out to the rural site. And then after we do that, we'll turn around and bring the shrimp back from the farm back to the urban site and use the urban site as the place that is the distribution point for the shrimp in the city. Okay, and let us know if you want to work with us some more. We can do these in the cities. The local jobs can never be outsourced because it's all about local. Thank you.